Hey everybody, I want to do a little video for you today about triangle similarity. We've been talking about how to prove triangles are similar for a while. We've done scale factors, we've done ratios of corresponding sides, and this is really just another way we can know triangles are going to be similar without having to look at all of the sides and corresponding angles. So these are what you might call little shortcuts into proving if triangles are similar, all right? And there's 3 of them. And if you are watching this video, I want you to pause and make sure you're taking some notes, and I would definitely entitle it Triangle Similarity. And then we need 3 different ones: angle, angle similarity, side, side, side similarity, and side, angle, side similarity. So go ahead and pause the video and get this set up with some notes if you're taking those right now, okay? All right, so hopefully you're taking some notes, and feel free to pause this whenever you need to write something down, or if I'm going a little too fast, because I do want you to have some examples down just for reference when you get ready to do your assignment, okay? And I will also post this document on Classroom where you found the video, all righty? So for angle similarity, here's what it says. If 2 corresponding angles are congruent, then the triangles are similar. So you can see how it looks here in the column. There are 2 examples, and we're going to do both of them, okay? So write that part down. If 2 corresponding angles are congruent, then the triangles are similar. What that thing I just started. All right, and then we're going to do both of these examples. Now the directions say if the examples below are similar by AA, and that little squiggly line, that's the symbol for similar. You may notice that it's part of the congruent sign. So it's just a little top squiggly part. Okay, so let's figure out if these 2 triangles are similar using the angle similarity shortcut. All right, so what we do is we compare these triangles and figure out, well, are the corresponding angles equal? Well, I noticed that both of these are 75, so that looks good. Now, I'm not told what angle C is, and angle C corresponds to angle F, so I'm not really sure. The only way I can know for sure is to check out angle B and see what's going on with that. Now, how could I figure out either angle E or angle C? What do you know about triangles and how many degrees they add up to be? They add up to be 180, right? So let's add these 2 together. Let's just figure out what angle C is. All right, if I add these 2, you get 149. And what's 180 minus 149? Well, that looks like 31. Okay, so let's go back to our statement. And if that's 31, then that means that this angle and this angle that are also corresponding, they're equal, and I can go ahead and know that 74 is also going to be angle E's measure because it corresponds to B. So what that means is yes. So we want to write yes, and then we're going to write the similarity statement. Okay, so let's just start. ABC is similar, here's the symbol, and then let's pick corresponding angles for the first triangle to match up with the second. So what corresponds to A? D. That's right, so D. And then we did B second here, so B corresponds to E, and then C corresponds to F. Okay, so those triangles are similar. So we showed that by making sure that at least a pair of those corresponding angles was congruent. All right, so let's look at this one down here. We don't have any numbers. All we know is that V and Y are congruent. But we actually kind of do know something else is congruent. You see right here at X, these triangles share a point. These 2 angles have a very special relationship. It starts with a V, vertical angles. And what are vertical angles always? They're always congruent. So let's think about this. If V and Y are congruent, and these 2 angles are congruent, are you pretty sure that Z and W are also congruent? Absolutely. It's no different than what we did up here. You know, if these 2 are congruent to these 2 angles, then I'm positive Z and W have to be the same measure. So this would be another yes, and we're going to write the similarity statement. It doesn't matter which one you start with. How about I start with X, Y, Z? XYZ is similar to triangle. All right, now what angle corresponds to X? I would say X from this other one. All right, they both share that. And then we went Y on the first, so what corresponds to Y? B. And then W, it corresponds to Z. So those triangles are similar at angle, angle. All right, the next one we need to talk about is side, side, side. So the three S's definitely represent side. And we're trying to figure out now if all the corresponding sides are proportional. That means we're going to set up some equal ratios, some fractions. Then we know the triangles are similar. So let's look at number 3 here and see what happens. All right, so we need to figure out what side corresponds from the first one to the second one. So it looks to me like 3 and 6 correspond. So let's do a ratio of 3 and 6. And then 5 and 10. And then lastly, 4 and 8. Okay, so what does 3 over 6 reduce to? Half. 5 over 10 is a half, and so is 4 over 8. So are all three of these ratios of the corresponding sides, are those equal? Yes. So this means, yes, these are similar. They're not congruent, they're just similar. And let's write the similarity statement here. So let's see. PQR would be similar to triangle. P corresponds to S, and then T with Q and U with R. All right. Number 4, we got to do the same thing. All right, so when it says up here that if the corresponding sides are proportional, that means proportional means you set up those ratios and they're equal. That's what that's meaning by that. So if you see that word, that's what you need to do to verify that. All right, so let's look at number 4. And let's pick some corresponding sides. Okay, these are oriented the same way, so that's easier to decide. All right, so 30 over 24. And then it looks like 32 matches up with 25. And then 35 and 28. So if you've got a calculator or even Desmos, just type these in. You can look at the decimal versions or you can look at the fractions that matter. Let's see. This one's going to reduce to 5 over 4. If those divide by 6. Let's see. 32 and 25. Not have much luck there. I think that one's going to stay there. 35 and 28 both were reduced by 7. So that would be a 5 over 4. All right, so here's what we got. A 5 over 4, 32 over 25, and 5 over 4. Are all of those ratios equal? No, they're not. So you could say, no, the triangles are not similar. And we don't need to write that similarity statement because, well, they're not similar. All right, last one. So we talked about angle, angle. We talked about side, side, side. We got one more. It is side, angle, side. All right, so we do need to talk a little bit about this one because it's not just any two sides and an angle. It's a side, an angle between those sides, and then the other side. All right, so we've got to talk about how this is really important that you know where the angle is. All right, the little statement we have here says if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. So let me show you what that means. If you've got two triangles and I know this side and this side are labeled, okay, I'm not sure if they're congruent, but we know this angle and this angle are definitely congruent. All right, then we also know these two sides are proportional. This angle has to be in between these two sides. You see how it's not out here by itself, not in between those two sides. I mean, the sides of the triangle form the angle is what I'm trying to say. So that's an included angle. So we need to see down here if either of these examples we've got are going to work. Okay. Here we go. Trying to erase that mess there. All right, so what we need to do is first check to see if the angle is where it's supposed to be. And we know K and N have the labels. Now we have a label for 8 and 6 and then 20 and 15. So this angle is definitely formed by those two sides. So this is an included angle. So we know it's okay where it's at. So let's see if the sides are proportional. So 8 and 6 are corresponding, and then 20 and 15 are corresponding. Let's reduce this by 2, so that's 4 over 3. And then let's reduce this by, let's see, 5. It's 4 over 3 as well. So it's looking good. These two sides are proportional and those two angles are congruent. So I would say yes, they're similar. And let's write the similarity statement. So JKL, similar to triangle, M and P. One more. And this one looks like it's a little harder than the other one. Okay, so we've got a triangle within a triangle. So let me draw the big triangle here. Oh, I'm not doing too good about that. All right, so maybe I won't do that. So let's see. Look at the big triangle, ABC. Okay, and then there's a little triangle, ADE, inside of it. So what side of the big triangle corresponds to 15? That will be 25. So let's check that proportion. And then same thing over here, 12 corresponds to 21 in the big triangle. Let's check the ratios first. If that don't work out, then we know we're done. Let's divide both of these by 5, or just check that in Desmos. So it'll be 3 over 5. Divide both of these by 3, I guess. So 4 over 7. Okay. Well, this is definitely not going to work, is it? Because those are not equal.